And welcome back. In this projectile motion question, we need to calculate the launch velocity so that the toy bird is able to strike the base of the wooden building. Now they've given us the horizontal displacement, which is 45 meters, its vertical displacement of 34 meters, and its launch angle. So now before we attack this question, there are four main equations we need to know how to implement if required. So the first equation is the change in vertical displacement, which is equal to the initial vertical velocity times the time plus half times the acceleration due to gravity, which will be 9.8 on Earth, times that by the time. Velocity squared is equal to the initial vertical velocity squared plus 2 times the acceleration due to gravity times the change in displacement. Then you've got the velocity is equal to the initial vertical velocity plus acceleration times time. And then finally, you've got the change in the horizontal displacement, which is your range, and that's equal to the initial horizontal velocity times time. So as the question suggests, this toy bird is being launched at 60 degrees with a velocity of u, and we have to break this up into its component. So this will be ux, and this will be uy. There's our right angle, and there's 60 degrees. So we can find ux using cos. So cos 60 is equal to adjacent, so ux over u. Therefore ux is equal to u cos 60. So ux is equal to 0.5 u. Similarly, we can find uy by using sine. So sine 60 is equal to uy over u. So therefore uy is equal to u sine 60, which is equal to root 3 on 2 times u. Now that we have an expression for ux and uy, we can then substitute these respectively into the following equations. So the first equation we're going to use here is the change in the horizontal displacement. So change in x is equal to uxt. I know my change in x, which is 45. My ux I can use in terms of u, so 0.5 u times that by time. So from here I can find an equation for time by making it the subject. So time will equal to 90 over u. Now that I've got t, I can then substitute that t formula into the next equation. So the next equation here we're going to use is the change in vertical displacement is equal to uyt plus half at squared. My change in y is 34. My initial vertical velocity is root 3 on 2 u. Now sub in the t value, which is 90 over u plus half minus 9.8. It's always minus because it's acting downwards, times that by 90 over u squared. So by subbing in t into that equation, we now have a full equation in terms of u, which we can then solve. So we can cancel out these u's here. So we have 34 is equal to 90 on 2 is 45, times that by the root 3, minus 39,690. If you put that in the calculator, that's what you get, over u squared. So moving this to that side, you get minus 43.94 is equal to minus 39,690 u over u squared. So make u squared the subject and then square root it. So we get u is equal to square root 39,690 over 43.94, and that gives you a value of 30 meters per second, and that's your answer.